We're asked to find the derivative of x raised to the x power. This is a particularly interesting derivative because, well, none of our basic derivative rules seem to cover this scenario. I mean, if we look at the two closest ones that we have, the simple power rule fails because our exponent is not a constant, and then our exponential differentiation rules fail because our base is not a constant. So we're going to have to think of some clever way of rewriting this function so that we don't have an x variable for both the base and the exponent. Let's try using logarithms. So what I'm going to do is I'm going to define y to be x to the x. What we can do then is take the natural log of both sides of this equation. And if you think back to your rules of logarithms from algebra, you'll see that this allows me to bring that x power out in front of the natural log. Now, what I'm going to do is I'm going to differentiate both sides of the equation implicitly with respect to x. We'll have to use the product rule for that x times natural log of x part, but nothing too complicated. And if you forget the product rule, it's the derivative of the first function times original second function plus the derivative of the second function times the original first function. Now, we can simplify that equation a bit, and what we'll do now is we'll multiply both sides of the equation by y so that we can have dy dx isolated. Now, if you'll notice, we have a y in our equation that we need to get rid of. If you look back to our original equation, you'll see that y is just the same thing as x to the x. So we can replace y with x to the x. And there you have it. We can distribute that x to the x into the parentheses, and that's our final answer. This is called logarithmic differentiation.